This training module will explain information needed for interpreting water quality transport curves for use with the Stochastic Empirical Loading and Dilution model SELDM. This is training module 7.02c. This presentation has 10 slides and will take about 5 minutes. This presentation was prepared by the U.S. Geological Survey in cooperation with the Federal Highway Administration. This module has 2 learning objectives. We will learn to describe the advantage of a water quality transport curve and describe the method for generating data with a water quality transport curve. A transport curve is a regression equation using stormflow as the predictor variable to simulate concentrations with random variation around the line. This hypothetical graph shows a linear relation between the predictor x variable and the response y variable. Regression is used to estimate the intercept and slope used to define the linear relation. However, there is also random variation in the y variable above and below the line for every x value. This variation should be normally distributed. SELDM generates a random value for stormflow, xi, applies the transport curve regression equation to get the average value of the dependent variable, y, and then adds a random term to generate a value for the water quality constituent, yi. Transport curves should be developed with the logarithms of the x flow and y concentration values because of the properties of these variables. We use the transport curve approach because the concentration of many constituents vary with flow in receiving streams. We have compiled a large data set, but very few event mean concentrations are available for streams. The water quality transport curves allow us to generate planning level estimates of flow index event mean concentrations from many instantaneous samples. This is a map showing the ecoregions and the location of the U.S. Geological Survey surface water quality monitoring sites with paired streamflow and water quality measurements. This map looks like there is a lot of data, but there is more than 7 million miles of streams in the United States, and most stations have only a few samples for a few constituents of concern. Available data and methods for developing and using transport curves are documented in USGS-TM4A7, which documents the Kendall-Teal Robust Line software, and FHWA-HEP-09-003, which documents our national data mining and interpretation efforts. The Kendall-Teal Robust Line software was developed to produce multi-segment transport curves as part of the SELDM implementation study. Several other programs were developed as part of the national data mining and interpretation efforts. The Surface Water Quality Data Miner, documented in the Background Water Quality Report, FHWA-HEP-09-003, helps process the data. We won't cover this in the training class, but I want you to know that it exists for your use. It has a number of tools, but the top 2 buttons allow you to make the Kendall-Teal Robust Line input files that can be used to develop transport curves. A populated version of the Surface Water Quality Data Miner is included in the SELDM training materials available from the U.S. Geological Survey. The first step in building a transport curve is to plot the data with streamflow in cubic feet per second per square mile. The blue circles are paired values of measured total phosphorus concentrations and flows in Sasko Brook in southwestern Connecticut. The concentrations in milligrams per liter and the storm flows in cubic feet per second per square mile are shown on logarithmic axes. The gray line is a water quality criterion for total phosphorus in receiving waters. The second step is to develop a 1 or 2 segment regression line with the Kendall-Teal Robust Line program by using methods documented in USGS-TM4A7 and FHWA-HEP-09-003. In this case, the data indicate random variation in total phosphorus with flow under base flow conditions and increases in total phosphorus concentrations with increasing storm flows. Under base flow conditions, there's a zero slope and the line has an intercept of 0.02. Above the breakpoint at 1.1 cubic feet per second per square mile, there's a log-log relation between flow and concentration. The third step is to use SELDM to generate a random population of values from stormflow. In this graph, the gray points were generated by using the transport curve with random variation. As we can see, when we do stochastic modeling, we do not need a tight fit. The scatter in the input data is reproduced by using the random component. In this training module, we learn to describe the advantages of a water quality transport curve and describe the methods for generating data with a water quality transport curve.